Okay guys, welcome back. So in the last video we found a simple example, right, in which we found relationship between c squared and t, right, but in which the mass was also given, the molecular mass of helium was given, and at STP, so we had to find the root mean square, right, value of that gas. So that was in the previous video. So in this video I'll be taking another example. In which we'll derive it. For another example, we'll use hydrogen, right? We'll use hydrogen for the sample, and we have to derive a relationship between the root mean square of a gas and the temperature. Now you know that c squared bar equals 3 RT by m. You know that c squared equals 3 RT, right? 3 RT by m. So if c squared bar is 3 RT by m, so for two temperatures for the same gas, you know that m is a constant, so c squared bar is directly proportional to t, because since m is a constant, you know that 3r by m is a constant, so c squared bar is k times t, a constant times t, so c squared is directly proportional to t, or c squared bar is, I'll take it as c squared bar is k times t. So for two temperatures, like as if you are using in the Charles law, so for two temperatures you can say that c squared bar 1 at temperature 1 divided by c squared bar 2 at temperature 2 is equal to the ratio of the temperatures. Alright. So let's take a simple example in order to understand this concept. So we have been given a sample of hydrogen like this. Right? The sample of hydrogen, and right, and we have been given that at 273 kelvins the root mean square velocity of this gas is 1840, and we have to find the root mean square velocity of this gas at 373 kelvins. So at 273 kelvin, so if T1 equals 273, you know that C1 squared by the root of that, root mean square velocity, right? Root mean square velocity means C1 squared bar at T1 temperature is 1840 meters per second. 1840 meters per second, and we have to find the temperature, we have to find the root mean square velocity, root mean square speed, right? Root mean square speed of this gas at 373 kg. Now from this equation, since you know that since the value of c squared bar increases with t, you know that with increasing temperature the value of c squared bar will increase, right? So the temperature has been increased, so c squared bar will be increased, or root of c squared bar will also be increased. So let's find out what is the actual value. Now, you know that the value will be greater than 1840, so let's find out what is the value of that. Alright, so you can take the simple example here. So if c1 squared bar divided by c2 squared bar is equal to t1 by t2, taking the root of both sides, you can say c1 squared bar, the root of that, right? C1 squared bar, the root of C1 squared bar, divided by the root of C2 squared bar, C2 squared bar, right, is equal to the ratio of T1 by T2 and the root of that. Right? So C1 squared bar has been given in the sum as 1840. So we have to find C2 squared bar. So we will isolate C2 squared bar here. So we have been given T1 and T2. So this is just a substitution. Another problem in which we have just substitute and solve. Alright. So let's take C2 squared bar here. C2 squared bar, the root of that. So that is my intention is, right? So I'll cross multiply here, is C1 squared bar divided by root of this one. So C1 squared bar, root of that one, divided by the whole root, right, divided by the whole root of T1 by T2, the root of that. T1 by T2, the root of that. Right? Alright. So we have just substituted the values to find this. So C2 squared bar, the root of that, is C1 squared bar has been given as 1840. Divided by the root of T1. So T1 is the temperature initially. So T1 we have been given as 273 and T2 we have been given as 373. So this is 273 divided by 373. Right? 273 divided by 373. So we have to solve this and find the value of this. Right? So I will solve it. Alright, so we'll get 1930. 1930. We get 1930 meters per second or 1.93 kilometers per second. Right? So these are also that we are getting. So this is just a simple example in which we found a relationship between the root mean square velocity of a gas or the root mean square speed of a gas and the absolute temperature. So we found a simple example and we found the solution for it. So that's just an example in which the kinetic theory of gases or the KTG plays another important role in the problems that you will be getting under gas laws. So see you next time with another video on gas laws.